Welcome to Enoch's videos, and today I want to talk about the reactivity series of elements, and specifically the reactivity series of metals. Before, we need to know what is a reactivity series. A reactivity series is typically a vertically presented model with the most reactive element placed at the top of the series and the least reactive element placed at the bottom. Sometimes the reactivity series of cations is quite hard to memorize, very hard, as students find it very hard to answer in a question paper. So I want to give you a simple memory to help you recall the reactivity series of cations, and it goes: please stop calling Layla Mercy a cute zebra. I touched lightly her curved mouth. Sarah got pissed. I repeat, please stop calling Layla Mercy a cute zebra. I touched lightly her curved mouth. Sarah got pissed. Each of those words, I want to tell you that it's representing a particular cation. For example, please stands for potassium, stop sodium, calling calcium, Layla lithium, Mercy magnesium, aluminium, jute carbon, zebra zinc, iron, touched tin, lightly lead, her hydrogen, curved copper, mouth mercury, Sarah silver, goat gold, pissed platinum. So you can also create yours which can help you to recall, but that one is so sweet. How I wish you could memorize it and you use it. One may ask, in the reactivity series of metals, why do we include hydrogen and carbon? Why do we include them there in the reactivity series of metals, yet for them they are non-metals? One, you need to know that carbon and hydrogen in this reactivity series are very useful because these elements are used in the extraction of metals. You should know that zinc and iron can be displaced from their oxides using carbon but not using hydrogen. However, you can also use hydrogen to displace copper, that is from the copper oxide. So we include them just because we use them in the extraction of different metals, that is from their oxides. Okay. What could be the importances, or at least one importance of the reactivity series? A reactivity series is just used to determine the products of a single displacement reaction whereby a metal A will displace another metal B in the solution if A is higher in the series. That is, if a metal is more reactive, then it can displace a metal that is less reactive. Only that. So why do we place potassium at the top of the reactivity series of metals? Is it the most reactive metal? Oh, I want to tell you one thing is that potassium belongs to the most reactive group of elements referred to as the alkali metals. But I want to tell you that it's not the most reactive element in the group. There are other metals that are more reactive. However, you need to know that as you move down the group, the reactivity of a metal increases. In other words, their size is increased and the tendency to attract the outermost electron reduces. So metals like francium, cesium, rubidium are more reactive than potassium. You find that for francium, in fact, it is not in nature, it does not exist because it's very reactive, reacts very fast, so it's hard to trace it in nature. However, we have metals like cesium, rubidium. However, at a certain level, that is all level, we don't normally talk about these metals, the cesium, the rubidium. So we normally start from potassium. Now that we normally study the chemistry of potassium rather than cesium and rubidium. That's why I may not find them here. However, if you are asked to choose from the table, definitely choose the one at the bottom or the one least in the group, the lowest in the group.